Quick, without a calculator, what is 12 times 7? For a lot of people, that is an awkward one. It sits just past the times tables in the zone where you have to stop and think. But what if you never had to do the hard version at all? What if you could quietly turn it into two pieces you already know cold and just add them? That is not a trick or a hack. A simple picture of dots shows exactly why it has to work every time. Start with a neat rectangle of dots, 5 rows with 4 dots in each row. Count them however you like, across or down, and you always get 20. 5 fours, 20 dots. Nothing surprising yet, but this plain little grid is about to prove something powerful. Now draw a line across it, 3 rows on top, 2 on the bottom. Nothing was added or taken away, so it is still the same 20 dots. But now count it as 2 blocks. The top block is 3 rows of 4, that is 12 dots. The bottom block is 2 rows of 4, 8 dots. 12 and 8 makes 20, the very same total as before, same dots, not one moved, just counted in 2 friendlier pieces instead of all at once. Read what the dots just proved. 3 plus 2, all times 4, equals 3 fours plus 2 fours. Splitting the rows, split the multiplication into 2 pieces, and the picture guarantees they add back to the whole. In general, A plus B, all times C, equals A times C plus B times C. That is the distributive law, one of the pillars the whole of arithmetic stands on. And it is not a rule you have to take on faith. You can see it right there, in 20 dots you just counted. The same idea works the other way. If you take the 2-row block away from the 3-row block, 3 fours minus 2 fours is 12 minus 8, 4. And that is 1 row of 4, exactly right. Splitting works for taking away as well as adding. Now watch it pay off on 12 times 7. Split the 12 into 10 plus 2, the friendliest pieces there are. By the law, 12 sevens is 10 sevens plus 2 sevens, 70 plus 14. 84, done entirely in your head, with no awkward step anywhere in sight. You can split downward as well, 9 times 7. 9 is 10 minus 1, so 9 sevens is 10 sevens minus 1 7. 70 takes 7, 63. Rounding up and correcting is often the easiest split of all. So a hard multiplication is never really a wall. Split one of the numbers into friendly pieces, usually around 10 plus or minus a little, and multiply each piece on its own. Then add or subtract the easy results. The dot array is the reason this always works. Cutting the rectangle never changes the dots, so splitting the multiply never changes the answer. Your turn. 13 times 6. Split the 13 into 10 and 3, do the 2 easy multiplies, and add. Pause and work it out. 10 sixes is 60, and 3 sixes is 18. 60 plus 18 is 78. 13 sixes cracked in 2 easy steps you already knew, instead of 1 hard one you did not. That is the whole method, working for you. One more, and this one looks nasty. 8 times 99. Do not multiply the ugly way. Split 99 into 100 minus 1. Pause and try. 8 times 100 is 800. Minus 8 times 1 is 8. 800 take away 8 is 792. A product that looked frightening, settled in your head, just by splitting 99 downward into 100 minus 1. Once you see it, this law is everywhere. Every mental maths shortcut is a clever split. Long multiplication on paper is just this law, applied digit by digit. And in algebra, expanding brackets is the exact same move. Split into friendly pieces, then recombine. So when a multiplication looks hard, do not push through it. Split one number into friendly pieces, multiply each, and combine. The dots promise it always works, and it turns one hard multiply into 2 easy ones. That's all for this video.